Hi everyone, I welcome you to this topic which is talking about connection of resistors. So resistors can be connected in either series or parallel. They can also have a series parallel combination. Okay, so we'll start with a series combination of resistors. Resistors are connected in series from the diagram shown below. Okay, so when you have a series combination of resistors, you would have two resistors having a common junction. If you look at resistor 1 and resistor 2, they are being connected there. This other side might be connected to something else and there something else, but at least they should have a common junction. So this is an example of a series connection of cells, and the following should be noted for the series connection of resistors. So resistors connected in series, they have the same current flowing through the circuit, and then the supply voltage is simply the sum of the individual voltage drops. So at resistor 1 you have a voltage drop called V1, and at resistor 2 you would have a voltage called V2. So when you add the voltage drop across that resistor and that resistor, they are going to give you a summation of the supply voltage. That's what that equation states. Okay, then the total resistance is simply the summation of the resistors. So if you want to find the equivalent or the total resistance in this circuit, you just add the resistor 1 plus resistor 2. Okay, another type of connection is simply what we call parallel connection. So the diagram below shows connection of resistors which are in parallel. They may have supply voltage like that. Two resistors which are connected in parallel as opposed to those in series, they have both junctions having the same terminal or connection. So if you look at this resistor, it's got that point. This point is connected to that point of the resistor. At the same time, the other point, which is this one, is connected to that other point of the resistor. So these two resistors are parallel connected, and they are both connected to this supply. So resistors connected in parallel have the given features. So two resistors connected in parallel, they will have the same voltage acting there. As you can see, this voltage is the one which appears across this resistor as well as that resistor. That's number one. Then number two resistors connected in parallel, the supply current is simply the summation of the branch currents. So if you look at this current which is coming from the supply, when it reaches this node, it splits. One is going that side and the other one goes that side. So if you add these two branch currents, they will give you the supply current, which is given by that formula. And then the total resistance of resistors connected in parallel is simply that summation. So you add the reciprocal of the resistors. For this example, we have 2, but no matter how many they are, therefore it will be 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and so on and so forth. Okay, here is an example. Find the equivalent resistance looking into the indicated port of the ladder network shown. Okay, so we have this ladder network. In this ladder network, we've got, they are saying you are viewing from here. So what equivalent resistance are you going to see if you are to view from here? We've got this resistor of 330, that one, this one, that one, including that one. Okay, so with the few illustrations we had on the previous slides, let's solve this problem. Okay, so on our solution, the problem was that, okay, so if you look at this circuit, you will realize that R5, which is 330 ohms, and R6, which is 680 ohms, these two are connected in series. So we can do a series combination of this, which is just direct adding. They are in series because they've got one point of connection. This point is connected somewhere else and this one somewhere else, but at least one point is connected. They are connected at one point. So you sum those with the series summation and we get that. So R56, which is a combination of resistor 5 and resistor 6, will be resistor 5 plus resistor 6, and this will just be 330 plus 680. That will give us 1010, and our circuit will reduce. Instead of seeing these two resistors now, we'll see these two resistors combined into one, giving that. This is a point of view. So the 330 stands, 680 stands, that one stands, that one, but where there's supposed to be 2 here, you have a summation which is 1010, and that's the one you're having there. So we go on. So our circuit had reduced to this. So with this one, you realize that R4 and the combination of resistor 5 and 6, these two are in parallel. So what do? We can do a parallel combination of those two. So combining R4 and R56, R56, which is simply a series combination of resistor 5 and 6, we are getting, that's the formula for parallel combination. So R total of these two is simply a summation of 1 over R4, R4 being 680, and 1 over R56, R56 being a combination of resistor 5 and 6, which was 1010. When you substitute those values, solving for RT as a total of these two resistors, that will produce that. So when you combine these two resistors in parallel, 680 and 1010, they will give us 407. So these two stand. This one stands, this one stands, which are these. This one stands, this one stands. No, this one stands, which is this one. And then these two, since they've been combined, they will produce that 407. We proceed with our combinations. Combining resistor 3 and resistor 456, which are in series, these are giving that, which is a series combination of simply having 330 being added to 407, and these will give us that as a total resistor. These are being maintained. Okay, we have that. Then we go to the next step where we are combining these two. Okay, so our circuit remains like this, where you've got R2 and R3456 in parallel. So a parallel combination of these two resistors, the resistor R2 and R3456, when you combine these in parallel, you're going to have this as your formula. So a total combination of those two will produce that, being R2, 3, 4, 5 and 6, a combination of those two resistors. This will produce 354. And then you realize that these two are now in parallel. So, and finally, a series combination of the two gives. So when you combine this one and this one, which are in series, they're in series because they've got one junction point there. So a combination of R1 and this resistor, which has been a combination of the number of resistors, will just give us this 330 we add into that one, and then it will produce 684. This 684 ohms is the equivalent resistor. That's the resistor you would see if you were to view your circuit from that side. Okay, hope this will help some people. Thanks for watching.